We have one more session before our longer break. All right, so buckle up for the next 50 minutes. We are going to learn how the incomparable James Hedberg creates his Instagram Reels and TikTok videos and rendered video writ large in OpenSpace. So here you are, James.
Okay, thank you, Megan. Thank you for asking me to share after all these years. It was in 2016, the very first time I pressed build on OpenSpace on it still works on that Apple laptop, and I still even ran OpenSpace on it within the last year for a little weird thing. But anyway, so I've been doing this a while. The topic is, of course, making movies. I understand that was sort of a requested feature for this workshop or for this thing, and it's been a large part of my life for a while, so this should hopefully sort of encapsulate it all. The answer to the question, why make videos? I don't know. It started as just like, let's see if I could make a little video. And eventually it turned into something between a compulsion, addiction, obsession, I don't know what, but every little thing that went, when you're teaching astronomy or physics and you have an idea, like you want to try and explain it to your class, usually you figure out a way to do it. Of course, I didn't have the planetarium for a few years during the pandemic, so I focused all my efforts towards the small screen. And it really took off. And this is just what you're looking at there is the timeline of all 300 or so, maybe more, I don't know how many more, short little vertical videos produced for largely Instagram. A TikTok I kind of stayed away from. It got weird. But Instagram was pretty good, and we had a lot of successes. And
Millions of views.
yeah, millions. I don't even know. I've stopped keeping track of those things.
More than 7.
The highest one is it's coming up somewhere. I don't know, 15
That's 5.1
million. Yeah, there's a yes.
You're living the dream of every middle school kid I've taught.
You can tell. Just look at me. Yeah, I know. It's been pretty good. Anyway, I think about why all the time. Why do all that? I don't have an answer. Neither did the people who started the whole project of SciViz back then. I don't know. Maybe they wanted to explain stuff. I love the history of science visualization, so you have to bear with a few slides about that. On the left, we have some Babylon tablets showing geometrical work. There's a star chart from 700 on the far right. One of my favorite underappreciated ancient scientists, Nicola Rem. You can see there in the little figure on the far right some little columns in a circle. That was effectively doing calculus 300 or 400 years before it got written down by Newton, like integrating those little boxes into a circle shape, right? And he's an amazing figure, Nicola Rem. Go read some of his stuff later if you want. And of course, the one that we all appreciate the most perhaps today, Copernicus's hand-drawn solar system. The thing I like the most about this is the hole that he punctured in the center with his compass. You can see just a little ring there on the right-hand side of the frame of the screen, right? That little thing above the O, Sol. He just must have been jabbing that needle in the paper over and over till it formed a hole. Their sun is there. Visualization really took off, I guess, or not took off, but got its footing when Descartes first had the idea of graphing things on an XYZ plane. He didn't call it XYZ back then. They had none of those sort of things. His axes weren't even orthogonal necessarily, but the idea of turning algebra into analytic geometry started there. So Descartes gets special mention. He also wrote down some really important rules for the direction of the mind, in which he encourages everyone to just draw pictures, basically. If you're trying to figure something out, draw a picture. It didn't work out for Descartes terribly well. A lot of his natural philosophy went way, way wrong, but his algebra and his geometry and so forth, that we stand by. But his idea of vortices and who knows going on out in the solar system didn't really work. But anyway, I still like him as a mathematical philosopher. And people did take his advice. You know, Faraday figured out electricity and magnetism without algebra, just using conceptual drawings, recorded in notebooks. And that's where we get the concept of a field today. Even non-science disciplines will use graphics, right? You can diagram sentences. Chemistry relies heavy on it. The periodic table is effectively a visualization of properties, right? Up, down, left, right, all mean different things. Physics, that's what I teach mostly during the day, of course, has tons of little visual helpers along the way. Even biology has gotten into the game with diagrams and stuff. They've had less success in sort of making it digestible, but nonetheless, yes. This is all the metabolic pathways. Anyway, if anyone in here wants to, use the powers of OpenSpace to tackle this, maybe. Anyway, but I guess what we're here for is the moving image, right? When do we start taking stills and turning them into animations and so forth? And that took a little bit longer to figure out. I never really thought of it this way, but then just looking back on this slide I had from another talk, right? This is Galileo's Sidereus Nuncius. And you can see his drawings of the moon on the right, showing the craters and valleys. And on the left, he had all of these sort of day-by-day observations of Jupiter with the Jovian moons, right? And he didn't know what he was looking at, but figured it out eventually. And really what he had done was compiled a short stop-motion animation of the Jovian system. Right? There was nothing like a movie back then. I don't even know if they had flip books, if anyone had invented a little flip book animation yet at 1610, but he has pages and pages where he's just drawn Jupiter with the little moons. Timestamps are totally off, because sometimes it's like 5 hours after sunset, and then other times it's a day later, and so you have to really sort of adjust for it, but anyway, that might be what I would think of as the first sort of compilation. This one is also really cool. This was in 1874, and this was, they had guns back then, right? And they had cameras, and so the idea was you just put a camera on a gun and with a revolver on it, and you could just take a bunch of pictures over and over and over. That's how this was done, showing the passage of Venus across the sun. I think, unfortunately, historians have digged deeper into what was going on here, and this might not be through the actual telescope that was used in the observation. They think this is a model of a little ball going across something else, but the idea is there, right? And in that case, it's fine. It's just a simulation, right? That's the same thing we do. Anyway, there's tons of these great old animations. Then, mathematics got involved, and here's one from over 100 years ago where they drew individual frames of different geometries and assembled them, ways to help figure out and teach math. And then, of course, Hollywood and the media and big production got involved, and that's really the legacy that we have to think about whenever we go ahead and make a space movie that we're hoping to put out into the world, right? People have seen lots of space movies, starting with Le Voyage de la Lune 100 years ago. We have Destination Moon from 1950. Here we have a painted backdrop, I think. That's what's going on there. Could be. Yeah, yes. Yeah, I don't know who did that one. There's no audio on this computer, right? Is there? Who am I looking? No. Okay. Well, there's some great sound effects going on here. Same with the universe from National Film Board of Canada, 1960. They're talking about Mars, which they'll zoom in on real quick and explain how the dark and light regions are vegetation. Almost certainly vegetation. Almost certainly. Moon trees? Yeah, well, they all got cut down. Yes. And then, of course, the pinnacle of 20th century space movies, 2001. I just put these on here. Hopefully you've seen them all. If not, go back and enjoy the history of what was there. Skip that one. Anyway, so with OpenSpace, this is what we have to work with today. The strengths. It's a real-time visualizer, right? And this is really from what I understand, one of the founding principles of the OpenSpace project is to be able to show data quickly, right? And to be able to present in real time. And then you mix that with the other big piece of software under the hood you don't see so much, but SGCT, and you can spit out formats of any kind that you want, from small screens to big screens to domes to VR, all just with a few little lines of code. And of course, the other thing that excites me as a scientist is the data-driven part of it, right? There's plenty of 3D modeling softwares out there. There's plenty of animation frameworks, all sorts of stuff. But this one is really founded on keeping the data as the, sacrosanct, one of those holy words, right? Yes, the data is the holy object here, and we want to treat it with respect, and so that's what appeals to me about it. Okay. Sorry, I'm going quickly, but if there are questions during, please stop and ask. I decided not to make this a interactive, try out some code things. Fans run too much, so. Okay, so some of the things that you do with OpenSpace. If you're just starting out, maybe you'll just want to make a fly through some valleys on Mars, right? This is a relatively easy sort of project to do, and there's amazing stuff there. You can spend hours flying through. Not sure anyone's going to watch hours of you flying through Mars, but it's fun enough to do on your own. One of my favorite projects is to always compare real observations with OpenSpace's simulation. So here's the eclipse, or the partial eclipse of the sun recorded by Perseverance, right? And so if you go hunker down on Mars in OpenSpace, exactly at the right spot where Perseverance was, zoom up at the sun, you'll see Phobos making its way right across. And it was down to this few seconds, I think, when I checked the timestamps on this. It was remarkably precise. Yeah. Thank you, Phobos. Yes. And I'm just trying to lump these into themes of things I've tackled. The other big thing is, taking us out of our human time frame of hours and minutes, right? The universe operates on different time scales. And that was partly what took astronomy so long to figure out, is that you can't just see it happening in an hour. It takes lifetimes and recorded information to understand the motion of the heavenly bodies, okay? And so OpenSpace is great at setting up a series of dates, right? So here we are every night, an hour before sunset, where's Mercury, for example? And this is the kind of thing you explain, if you teach astronomy, you explain this over and over, like sometimes you can see it, it's always near the sun, but just seeing a little clip like this to me, really makes it clear. You can see it going around the sun in a circle. We all know that it does that, but but you don't get to see that. I mean, Mercury itself is hard enough to see. Who's seen Mercury? How many people? I guess this is not a good sample size, right? But I've heard it's like 1 in 1,000. 1 in 1,000 average humans has actually seen Mercury. Okay, there. Yeah. All right. You're the representative. I think I saw it. Okay, other and non-space too, right? There's probably a few non-astronomy people in here, hopefully. Yeah. Anyway, so here's some tracking of a bald eagle data transmitter. So I don't know really what you learned from this, other than eagles like to hang out near the river, but I don't know. Just an example of using some data, non-traditional data sets in here that are remarkably easy to import and communicate. Okay, so there'll be a little tutorial type thing here coming up. So all these slides will be online, either on my page or OpenSpace's page, and so you can go back and look at them. And there's really, I guess, 4 ways of making videos with OpenSpace, I think. Maybe more, but these are the 4 I've heard of and used myself. There's always just capturing your screen, right? You can, what's it called now? Snapshot or they changed the name. Huh? Snippet? I forget what to type, but somehow it always knows what I want when I want to take a screenshot. Anyway, you could just record yourself on OpenSpace, save it as a video. That works. If you want to get a touch more fancy, then you could output the display from OpenSpace into OBS, and that works as well. That's a pretty useful technique. But the topics 3 and 4 are really what I think expand the possibilities of what you can do with a OpenSpace media production. And so the first one is session recording. That one is built into OpenSpace and is, it's right there in the GUI, and you can use it straight away. It's really good for things like making, semi-cinematographical sort of flybys of planets. Just the main limitation is how good you can fly. So practice flying, but then you can record. I'll show you exactly how to do it in a second. You can record your motions and then have it spit it out. And it does so really quickly too. That's the great thing. If you've ever made animations or videos with Blender or something else like that, you might have to let it run overnight to render all the frames, or maybe even send it to a render farm somewhere far away. Here you can make the whole movie right on your laptop, and you can be the whole studio. The other, I guess, it's a little awkward to change all of the GUIs and buttons and stuff during these things, but you can still do it if you want to play with various parameters of things. It can be done in this method, session recording. But it is limiting. You can't do too much all at once. And there are a few little, hiccups now and then. So here's a descent into Gorgonum chaos on Mars. And if you look closely, you can see the terrain sort of hiccuping now and then. And that's as bits get loaded in and as new parts get updated. And there are ways to get this to be better. I'll share some little tips later on. But those little flickers, I mean, maybe you can correct me if I'm wrong, but I don't think they're fully gone away yet, no. But there are ways to alleviate them and make it a little bit better. Most people don't notice them, but every now and then you get some clever observers say, why is it glitching out? And so how do you begin to do this? The first step is to sort of figure out what output you want. Is this going on a phone? Is it going on a screen? Is it going on a dome? Is it going on whatever thing? And so in there you can set, and I think this is coming up next, right? Yes, Alex is going to tell you all about this, the SGCT config stuff. So don't worry about capturing it all down right here, but basically for phone stuff, you can see if you're making something for a short vertical screen, right? This line right there gives you a aspect ratio of exactly what you want for that. And so here's a sample session recording that's going to happen right here. So we name the recording, go down to the little button on the bottom, press record, go do your fly arounds. Usually this takes like 5 or 6 trims to get the right exact flight path that you wanted, but once you get it, then it's saved there. The next step would be then to play that session recording. And you can see down on the bottom right, what you're going to do is click that little output frames thing. And if you're not familiar with what that means, I'll talk about it in a second. But basically, we're spitting out a few hundred or a few thousand PNG files that will then assemble into a video later. I'm not that fancy, so I usually work at 30 frames per second to save my hard drive. But I assume you can do 60 or whatever you want, yeah. Anyway, then you press play and it'll go through. You'll see it replaying the video. Sometimes it plays it faster, sometimes slower, depending on what resolutions you've picked. But generally, it's remarkably fast. And then in the end, you end up with a folder filled with images. Fortunately, they're all in sequential numbered order, which makes importing them into a thing like Premiere Pro or After Effects or Final Cut, any of the nonlinear video editors, is a breeze. It's just import sequence, and it takes care of the rest. And then you have an editable video. And so there's the screenshot from Premiere Pro, and this little bit right there, that's the assembled video frames. Okay, so that's the basics, and that's how I started for a long time, just doing that sort of thing, making a session recording, and then that was about it. And that works, and that's great, and you can do tons of fun stuff with that. If you want to take it to a next little level higher, what you'll find often in video composition software is the idea of layers. Right, so if you use Blender or other 3D things, you'll know that there are many, many different layers available to you as an output. OpenSpace doesn't have that built in like on the surface, but underneath it is there. You can decide what different things you want to show. And so, for example, if I'm making a video showing the motions of some mission that has trails, orbit trails, like you want to watch something going around the moon or a satellite going around the moon, you'll have trails on it. And so I will generally render out 3 or 4 sets of all of those images. Some with just the stars, some with the Earth, some with the moon, some with the labels, some with the trails, some with the date. I don't know what my record is, maybe 10 different layers at some point. And if you use the same session recording, then it is all identical as far as the timestamps and so forth. Yeah?
So you can use the same flight path from the same session recording, but turn on different assets within OpenSpace?
Yes, exactly, yes. So. We would say we would hide all the trails and then hide everything but the trails. movies, right? And then the thing that's really good for is that if you want to add, some special effects. And so here's one. Goodness. Okay. So you can see on the left, I have added a little blur, a little glow to the trails of the, what is this, the capstone? Yeah, this is the capstone going around the moon. And it just adds, it's like, if you want to make movies, you got to make them exciting and a little pop, get a little pop. So now you have just the trail layer, you can add a little blur to it, and it kind of glows a little bit more.
And that was something just available to you in After Effects. You didn't code some special trail glowing thing.
No. Yeah, so at this point we're in just consumer grade
You just
effects.
make
Yes.
this layer glow.
Yes, there's a dozen tutorials about that I'm not qualified to give, but someone else is, and that's where I learned it. Trail, it's called Bloom as usual, and there's so many of these things, so many little layer type effects that you can do. I also like to separate out the date from all of my film, all of the media's movies, right? So that the date is its own layer, just scrolling through like 1,000 PNGs with just the date, and then you can import that as another layer, and you can then have some flexibility, and you don't have the traditional OpenSpace date on the top left. You can move it wherever you want, make it come and go, and that's a useful technique. Anyway, the session recording is very well documented, all right here in the documentation, and they'll walk you through it again if need be, and it works. It works great. I don't know if there's any other details about it that, if anyone's ever used it and come across troubles, I can certainly help now or later. But
Ken just had a neat comment that when you have it in the text file format, you can even add a script into the recording later.
yeah, I haven't. I think I tried that once. So you do a session recording. You have to choose whether you want it to be in a text file or a binary file. If you do it in the text file, then it literally, you can see every 30 times a second it's sending a new command. And so you can go in and edit that yourself later if you mess something up or want to redo something. Yeah.
What is the advantage of the output to OBS versus the third option? We use the OBS output, so what is the advantage of the third one over that one?
Yeah. Why did I skip number 2, the OBS?
Well, I was
Yeah.
just curious what the general advantage.
Yeah. So as far as I know, what OBS lets you do is record a video file, right?
Yes.
After you do the OBS, after you record with OBS, you're gonna have an MP4, right? You just get that. So the number 3 lets you record, or lets you output each frame individually, and I think that gives you, in the end, a lot more flexibility over what you can do in post-processing.
Also, you have the advantage of you can fly the flight path once and then have multiple video outputs. So you could do a horizontal and a vertical
Yeah.
video output in the same one.
Yes. Yeah. Yeah.
And also, it has the advantage that if you wanted to make the video, let's say at 4 or 8K, and your computer couldn't handle running your scene at 4 or 8K at 30 or 60 FPS, and it got chunky when you tried to run it, if you use the if you use OBS, it will record it chunky, just like you see. But if you use the session recording, it will wait and make it perfectly not chunky.
That's the issue that I have. So with my laptop, I only use this.
So session recording is just data.
Even if you run
Yeah.
Session recording
Yep.
is just data.
Yep. Yes. Exactly. Yeah, I think maybe what Micah just said is, if you see there, I have on the top, the resolution is different than the window, right? So I have a higher resolution images than I'm seeing on my screen, which makes it way, yeah. I think I would never look back at this point. Yeah. That's been a point of discussion. It might, now they might.
It should, there's a setting that you can set to output transparency, which means that if you don't render anything, it's just going to be completely transparent pixel.
Yeah, I think I usually use a blend mode that just doesn't worry about that, but I think we can now. I haven't tried it, but I think so. Okay, so that's the session recording. That involves you like flying with your mouse or a joystick or something, pushing buttons on the keyboard the whole time, and that's, like I said, it's great. I use it all the time, but if you want to go one step further, that is to then make a robot do all the work, right? And so that's programmatic control of OpenSpace, and this is really, I think, where the powers are visible. So we always talk about, like, if you're promoting a planetarium or talking about space, you always hear these lines every day at noon, or what's the other one? If you look to the southern skies about 40 minutes after sunset this week, you'll see tons of these phrases that they make sense if you know astronomy, right? But they tend to just sort of zip by people's heads, really what they mean. And so it got mentioned in this other session, one of the sessions this morning, but if you're not aware, you can control OpenSpace with codes outside of OpenSpace. It's a little complicated. It's getting easier. And that's what I've been using for a long time now, is using a Jupyter notebook or a Python script to control OpenSpace. All right? And so once you have that power, once you have that connection happening, then you can essentially do all the cool things that, play with time in such a way that you wouldn't be able to do with just left and right arrow buttons going faster and slower. Okay, and so that's what we see here. There's a Jupyter notebook. This is what, in physics class we use these things all the time. This is what every intermediate physics class is using to talk about coding and science, is Jupyter notebooks. So they're ubiquitous. There's tons of examples made by Micah and others on the OpenSpace GitHub. And they're fantastic. And so what happens after we run one of these, right, so on the right, you can see I'm going to run a little bit of code, and on the left, you see OpenSpace trucking away. It's changing. It's just running through day by day by day by day. Okay, and so down at the very bottom of the screen right here, you can see I'm telling it to also take a screenshot. Take a screenshot. So it advances the time, takes a screenshot. Advances the time, takes a screenshot. And now you have a year, or however long you did it, a year of motion. There's a little bit of subtleties involved. You have to convert. You got to go through different date-time formats. But everyone who's struggled with astronomy data has done that at some point, so it should be experts by now. The code is remarkably not very complicated, and I'm sorry I haven't used the new version. I know there's a new version of this that is less complicated, and I plan on adopting it. So this is going through, this is Python talking to OpenSpace through JavaScript, basically, or through WebSockets, sending JSON messages. Now we can skip one of those steps.
Yeah, now you can just write the Python.
Yes,
and
okay.
Internally it bundles the message.
Yes,
for it.
okay. So that's my project for the next is to convert these things to the new version.
And those two lines would just say OpenSpace.takeScreenshot.
Fantastic.
Yeah.
Instead of message equals JSON dumps.
Exactly. And WS10
Yeah.
would just say OpenSpace.takeScreenshot.
And I wouldn't no longer have to guess what the topic number was,
Exactly.
or the type, or all that stuff. Awesome. So what a world we live in. Anyway, so once you do that, you can make classic intro astronomy teaching tools, right? So we all spend, maybe a class on analemmas, right? And you can go take them yourself with pictures, and that's an even better exercise. But here we can see it unfolding over a year in OpenSpace. And since we are using the programmatic, like the Python 2 chip to ratchet away the dates, right, we can then move the camera somewhere else and take the same series of dates. All right, so that's what you're seeing there. On the bottom is the view from the ground over a year, every day at, I'm guessing, not noon New York time, but sometime in the morning. And then in the upper panel is the view of the Earth over that same sequence of dates.
So you just like flew to the angle you wanted, ran the script, then flew to the next angle you wanted, ran the script.
Yeah. Yeah, that's why this is different than session recording, because session recording also records the camera. So you can't like change where you're looking after you've done a session recording.
So James,
Yeah.
the solidified line, is really just facing the sun without the glare on it. It's another layer.
The thing that actually shows the analemma path.
Correct.
Yeah, that was done as a layer afterwards. I probably just took a picture of the sun.
Yes.
Yeah, that's what you're saying. Just
Sun without
I got rid of the buildings, got rid of the atmosphere. It was just a little sun, and I made 700 pictures of the little sun, and then squashed them all together into.
I'm sorry. Mike and I have talked about this.
Uh-huh.
Now see you actually doing it.
Yeah, so some of these are not going to be doable. Like OpenSpace wouldn't be able to just make that. That would be post-processing to make that line.
Yeah.
Yes.
In this case, it is a layer. It's just an output.
Yeah.
Recorded in OpenSpace. Just
Yep. This one I think had no post-processing. This is the famous Manhattan Henge. And this is my plea, as always, to get the shadows into OpenSpace. I think it would just, as soon as we have some, so this is an experimental branch from someone else's project in which they built some shadow casting into it. And I played around with it a bunch, and I think it would be a tremendous feature to have in there. Anyway, Manhattan, we've just missed it, right, Jackie? No,
Yeah,
just
we need
happened.
Shadows.
Yeah.
I will approve the shadow.
Uh-huh.
Please.
Anyway, and so with this scripting, you can also then do all sorts of amazing, like, astronomical queries, right? You can get the sunset time for every day, for every location on Earth, whenever, like, and then you would just import that, or tell OpenSpace to take a picture 10 minutes before sunset. That's what is going on right there on the bottom. Or sorry, that's before sunrise, but doesn't matter. For as long as you want. And then you can answer the questions like, what does it look like 10 minutes after sunset? There's some other technicalities there, just getting everything to talk to OpenSpace nicely, but taking the pictures used to be as complicated as this line, but now it's even easier, which we'll update. And so here's an example I made a couple months ago, just very basic, showing 2 weeks of what Saturn and Venus were doing back in January. Okay. And these are great. This is if you run a planetarium and you want to tell your constituents what's going on, right? This is a fantastic way to do that. There are other softwares out there, but my heart belongs to OpenSpace for this. With the layers, you can...
James, can I just ask on this
yeah.
one? So how much, like, the font, the text, the labels on the constellations, which part is you post doing something to this?
That's a good question. So the part of this that is post-processing is the fact that you can see Saturn's glowing little thing and the trails right there. That's post-processing.
The Saturn with the arrow is an image file embedded inside of OpenSpace, right?
Yeah. I have the other things I will answer in a second. Okay.
Yeah, but also,
Yeah.
the font's not the standard font.
Yeah, I have. We'll get to that.
Oh, okay,
Yes.
all right. I don't want to spoil.
It's okay. No, it's a yes. Another cool button or thing to play with is the field of view. It's kind of hidden. It got hidden even further in the most recent version. Now it's buried under a few layers of menus, but it's still accessible. But you know you have a zoom lens hidden in OpenSpace, and every camera has a zoom lens nowadays, and it's a really good one to play with. It doesn't work in the dome, but for you making stuff for the flat screens, it works great. And so this enables you to set the field of view. You can set it programmatically during a sequence. And you can be a little bit more artistic with your renders. So here's Apollo flying through Manhattan on the moon. It does have the original audio, yes. But you can see, like, the field of view is like, imagine if your camera didn't have a zoom. Yeah.
The parameters to be like the dome resolution and still export for that?
Yeah. You mean not with the zooming
Or just in general?
In general, yeah. I have a little slide on that in a second. Yes. Anyway, field of view is one of my favorite things. We can also play with non-linear time. So maybe some parts you want to go slow or fast, and then you want to slow down, like we are right there, so that you can see the actual eclipse happening. Right. So that just takes a little bit of math to figure out a function you want to use for time. But if you like a little math, if you're not afraid of a little math, that's all it takes. Astronomical timescales, like I said, like what does the sky look like over 7 years? Those are profound questions that we don't get to experience as humans, right? We can see it once a month, maybe if we're lucky, and over the course of a decade, kind of remember what's going on. But to see it unfolding over these non-human lengths, timescales, to me is really powerful. So that's Venus. What you're seeing is Venus when it's a morning star, and then when it switches to being an evening star. Which again, we all know. Everyone knows that Venus is the evening star and the morning star, but it doesn't. For me, it doesn't click until I see it. Anything we have in the GUI, as Alex has mentioned already in the session, you can make happen programmatically, right? And so here we change a texture in the sky a few times a second, right? That's just animating the layer that the constellation art is. You couldn't do that that would be really hard to do manually, right? Click, 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 click. So that's an example there. This one's not going to work because the audio isn't working, but here I've synced the star colors to the audio, right? So the amplitude of the audio is changing the RGB values of the stars. This is more in the bucket of fun, but this one was sort of full programmatic control, right? So I told OpenSpace to grab another year of climate data, put it on the Earth, make it go around once, and do that 100 times, and then stitch it all together in a big matrix like that. It took as much time to write the script as it did to do it manually, but now I know how to do it for the next time. Some experimental features I'm working on is one to, it's always been difficult to stand in one place in OpenSpace and look at a thing in the sky, right? If you struggle with that, you're not alone, right? It tends to move you all over the Earth if you're trying to aim at something. And so I have a little overly complicated, ornate, but I think functioning method to sort of track an object through the sky. Sometimes it goes below the Earth, but that's just what happens. So there's the moon. Mercury is really cool. If you watch Mercury, right there you can see it going through, behind the sun, under. And oh, this was this one just happened in January. Did anyone see this? Yeah, yeah. I got it. It worked from my backyard. It was pretty cool. But here we're adjusting time. We're anchored on Mars, and we're playing with the field of view all at the same time with the script. And sure enough, it was right on schedule. Okay, so your question, other formats, absolutely. Like you can spit this out to full dome fisheyes, you can spit it out to VR equirectangulars. This is an example of the Ptolemaic star positions. I got really into Ptolemy a while ago. So here's a video that is full 360, and those are Ptolemy stars, so where he recorded them a long time ago. And they're pretty close. They're a little funky, some of them, but any format, that's the great thing. It's sort of agnostic to formatting. The post-processing, the only one I'll share there is this fun thing I got into a while ago, was playing with depth of field. Right? So this is, again, like a real camera will have some focusing abilities. So here you can see on Jezero Crater, we're changing where our focal plane is, and it's hard to say how useful this is going to be for like deep space applications, right? When everything is just really far away. But if you're doing stuff on the surface of a planet, then it does tend to add a little bit of photorealism, I guess. I don't know what the word is, but.
So did you get the Z-depth from OpenSpace?
Yeah, Alex told me how to do this a long time ago. Just sort of accident. I don't know. Yeah, I don't know if anyone's ever used it since then, but no. Yeah, I can. It is there. You have to add. That's a custom job.
It's a separate code. Yeah, it's a separate render layer. You brought it in here.
Yeah. Yeah, it's not even, it's messing with some of the internal OpenGL code to do it, but there's no reason it couldn't become a button later, right? But yeah, and then so you see the Z pass on the lower left, that's the black and white, and then that becomes the sort of blurring amount later.
I still use this as one of the examples why it's great to have it open source. Because at some point you asked me, it's like, if you can render out the Z layer. I was like, what the fuck? Like, okay, whatever. Like sending it over, and then you send me back the Apollo 11 landing. It's like, Jesus Christ, I didn't even know that was possible.
Yes. Yeah, I agree. Yes. Okay, so Jackie's question, customizing things. You can, and you should, right? So you can change whatever font, you can change the labels to be whatever font you want, right? At the moment, they happen to be not one that really rocks my world, but if you have a branding for your particular planetarium or institution or just personal taste, you can change it. You just have to drop it in the fonts folder and adjust your CFG file. The dates, I guess I haven't played with the new thing that shows the time zone, but maybe that will be maybe that will make this easier. But usually when I report out that, like if I'm saying it's 7 o'clock, you're gonna have to go out and look in New York City if you want to see this thing, then in order to get OpenSpace to spit out the right time, you have to play with the UTC offset.
It's only for the GUI, the new
It's only the GUI. Okay. The labels, where are my labels? Yeah, here, so instead of the labels, which we all know have some peculiarities, I've made little billboard images for basically everything. So every planet has its name and arrow, and so I attach those as assets to all of the things I want to talk about. And that way, again, I can just be a little more in control of what's going on.
We have examples of those in OpenSpace, Earth marker and Sun marker.
One of the little things I mentioned before, like this helps me with the tile flickering, and it's a little known slider down there, but if you see that level of detail slider, if you're making a video, I'm just throwing this out there, if you're making a video and you find that the terrain is not behaving too well, you can try cranking that number up. You can crank it up a lot. And it will sort of improve the what's going on in the background with the terrain, and you get less of that sort of jumpiness. And you don't even have to stop at 50. You can go up to like 200 or 300, and it gets
What is it doing? It is affecting how far away from the camera the high resolution tiles get loaded. So the higher the number, the farther away in the distance it will load higher resolution tiles. So as you increase the number, it also costs more rendering and performance because it's giving higher resolution to the load way far in the back where you don't necessarily need it. But in the case of making the video, you don't care about the
So
performance.
that's why it's not gonna scroll.
Correct.
Yeah, I wouldn't crank it up to 200 in the planetarium.
You'll get like 5 FPS.
Yes. But if you're just rendering frames, then it can
It's
go.
all the real data, right?
Yeah, it's just saying, give me the highest resolution stuff you got right now. Don't wait for me to get close to it.
Exactly.
Yeah. And I'm not gonna, this doesn't make any sense without sound, but I've played a lot with hooking up OpenSpace to various sound systems, and that's been a lot of fun. And in conclusion, I guess, like I said, I started this 10 years ago. After the build-a-thon, this was the state of our planetarium. It was abandoned. I don't know if anyone knew that. It was basically forgotten about. I decided to bring it back to life. And it's all like none of this would have been possible without OpenSpace there. There's no way I could have told the administration of the college, we want a new planetarium. Just do it, right? They're not going to do it. It took convincing, and part of the convincing was building a large audience for the planetarium, and OpenSpace was critical in that. We also now have software we can run on it, on the dome, and that's what we're doing all our shows with regularly. And it's right up the road. So it's if you're in the area, definitely check us out. Come by. You can eat snacks there. We're less fussy. Yeah, no carpet, and maybe one day we'll get new seats. Anyway, so the title of this talk was So You Want to Make a Space Video. It's modeled after the famous Glenn Gould little piece called So You Want to Write a Fugue. I will leave you with that to read it at your leisure, and thank you. I think you have a break now, right?
Yes.
Yeah.
Hey, so next we have a break. So we're taking a little bit longer so you can stretch your legs, get some chit-chatting in. So 20 minutes.